All right, guys, my iPad is charged. Let's go ahead and finish this lesson. So we're learning in this section about minimums and maximums. And another word you'll see for these, sometimes you'll hear them talk about extrema or extreme values. And that's what we mean by minimums and maximums. Okay, so I'm going to talk about some vocabulary first. So let me go ahead and set up a picture. So we're going to draw a graph. And this graph is going to kind of look like a lopsided butt. So it's going to look something like that. Okay, and we're going to talk about a couple different terms. So suppose we're going from some A up to some B values. So those are your X values, and this is what the curve looks like. So when we talk about, for example, an absolute maximum, what an absolute max is it is the highest point on the entire graph, so on the entire interval from A to B. So in this case, it looks like our highest point is at the left endpoint, right? This is our absolute max on the entire interval. And of course, if we talk about our absolute min, and our absolute min is our lowest point on the entire interval, A to B. So in this case, the lowest point in the entire interval would be at the bottom of the right cheek. So this would be my absolute minimum. And of course, we're going to use max and min to mean maximum and minimum, but it's the same thing. Okay, now these are important, and we're going to talk about them today, or in the future quite a bit. For now, we're going to talk, though, about something called a relative or a local maximum. And what a relative or a local maximum is, we have a relative or local maximum at a point if it is the highest value of all points nearby. So what that means is if you looked in a small neighborhood to the right and to the left, that would be the highest point. So for example, right at the top of the crack, this is our relative max. Because if we look either to the right or left a little bit, it goes down on both sides. And of course, the other side of this is if you have a relative or a local, and those terms are interchangeable, a relative or a local minimum, that is the lowest value of all points nearby. And again, if you look, so at the bottom of both cheeks, we see a local min at the bottom of, somewhere more around there, we see a local min or a relative min, and again, those terms are interchangeable, at the bottom of each cheek, because on both sides, it's the lowest point nearby. The function goes up to the right and to the left of those. You might ask about the endpoints being local maxes or local mins, and just as a note, we do not generally consider endpoints as relative mins or maxes. Just because we don't know necessarily what's happening on the other side. So that's not something that will ever be asked about. So we don't consider endpoints as local mins and maxes. Okay, so now you're saying, great, these local mins and local maxes look really fun. So how can I find a relative min or max? How do I find a relative min or a max? And here's the key. Thinking back to our graph, well, where do we see? We have these local mins where the derivative is 0, and we have this relative max where the derivative is undefined. Oh, so they happen when your first derivative equals 0 or is undefined. And of course, these are the critical points. So the critical points are where you have a local max or a local min, perhaps. Okay, so that again should make sense, right? We look at the mins happen, we have a slope of 0, the max happens there. If we had a slope, say, of like positive 1, right? If you have a positive slope, there's no way that could be a min or a max because the function is still going up on one side and it's going down on the other side. Same thing if you have a negative slope, right? So you're only going to be able to have a relative min or max if I have a 0 slope or an undefined slope. So then, okay, so then your question becomes, how can I tell if a critical point is a min or a max? How can I tell if a critical point is a min or a max? Okay, so let's talk about what's going on at a max. Here's what a max looks like. A maximum looks like that or like that. So what's happening there is at the left, your slope is positive and then your slope is negative. Your slope is positive and then it's negative. So the way we define a relative max, so again, this is relative. A relative max is when your f prime switches from a positive to a negative. Okay, and as for a relative min, Well, of course, the opposite is what you'd expect, and you would be correct, right? If we have a relative min, it looks like that or like that. And at a relative min, your f prime is switching from a negative to a positive. So you have a negative slope, and then you have a positive slope, right? Your function is going down, it's decreasing, and then it's increasing. And that point where it switches from a negative to a positive slope, that's where you have your relative min. Okay, so how can we see where the derivative is switching from a positive to a negative or vice versa? If only we had a tool that told us where a function was positive or negative. Oh my God, we do. We make a sine line graph of f prime. Yes. Okay, so that's the key. A sine line graph is going to tell you whether your derivative is going positive to negative or negative to positive. Oh, also I should talk about one more thing. Now we'll get to that eventually. Okay, so for example, let's say we have the function f of x equals x cubed minus 3x plus 1. And I ask you to find the x coordinates of all relative mins and maxes. Okay, so here's what this is generally going to look like. You're going to find the critical points first, because those are the only points where they could occur. So we're going to find the critical points. And then after we found the critical points, then we're going to make a sine line graph of f prime to check whether they're mins or maxes. Okay, and then we'll talk about how we write this up. So let's find f prime and then do a sine line graph. So my f prime is 3x squared minus 3. So I set that equal to 0. Remember, critical point is where your first derivative is 0 or your first derivative is undefined. Okay, now, obviously this is a function which is not going to be undefined anywhere. So we'll factor out a 3, so we have x squared minus 1. So we see my critical points here are at negative 1 and 1. Okay, so my critical points, 1 and negative 1. So I'm going to make a sine line graph of f prime. So when you're doing these sine line graphs, label it as f prime. Okay, so I'm going to split it up at 1, and I'll split it up at negative 1. Oops. Now, here's the key. I'm trying to see, like, where is f prime positive or negative? Where is your slope switching from a positive value to a negative value? So what that means is I need to plug in to f prime, which should make sense, right? Because we're making a sine line graph of f prime. And the other tip I'm going to give you is plug into the factored version. So when you take your values, it's a lot easier to just plug them in there. Because we're trying to see where is f prime positive or negative. So, okay, we'll start with x equals 0. So your f prime is 3 times negative 1 times a positive 1, that's a negative. When you plug in, say, 10, or any number bigger than 1, right? You can plug in 2, 5, 10. When you plug in x equals 10, you have 3 times 9 times 11, that's obviously positive. When you plug in, say, negative 2, you have 3 times a negative, that's going to be positive as well. All right, so in this case, we're going to use the sine line graph to see where do we switch from positive to negative and vice versa. So at x equals negative 1, your f prime switches from a positive to a negative value. So your f prime value switches from positive to negative. So thinking about our picture, right, we have a positive slope and then a negative slope, so that means that we have a local maximum. This is how you want to write it up on the AP test. This is how you want to write it up on your homework and practice this. To finish answering the question, if we look at x equals 1, your f prime switches from a negative to a positive. So my f prime switches from negative to positive. I see that that's going to be a local minimum. Okay, so that's the answer to my question. I found the values and I justified why each one was a local max or why each one was a local min. Remember, local is the same as relative in this. Okay, one more thing I wanted to show you. Let's look at an example where we have no sign change. And by the way, if you doubt these answers, feel free to graph this function, right? If you graph this original function, you will see that it does indeed have a max of negative 1 and a min at positive 1. Okay, so suppose we have no sign change, like f of x equals x cubed. So when you take the derivative there, of course, you get 3x squared. So you make a sine line graph here of f prime. So here's 0. You plug in a 1, you get positive 3. You plug in negative 1, you get positive. So what happens here is because there's no sign change at x equals 1, x equals 0, the slope is positive then positive, that means it is neither a min nor a max. Which actually makes sense, because if you graph the function x cubed, right, the function goes up and then it chills, then it goes up. So at this point, we do have a critical point. This is a critical point where the derivative is equal to 0, but we can see very clearly from the picture it is not a min and it's not a max. And the sine line graph shows us that because we don't go positive, negative, or negative, positive. Okay, so that's what this lesson's about, sine line graphs and determining what a relative min and relative max are and where they occur. Hope this helped, and I'll see you guys soon.